Hello everyone and welcome to another video of Vivek Learns. So in this video series we are solving the level 1 of pep coding, and in the last video we have solved two questions of the same. So in this video we will continue the series by solving the next question. So the next question is prime till n. So let's try to understand this question first. Let me go to the question. You have to print all the prime numbers between a range. Take as input low the lower limit of range. Take as input high the higher limit of range. For the range, print all the prime numbers between low and high, both included. So the expectation is we will be given two inputs and we will be requiring to print all the prime numbers between those two numbers, right? In the last video we had saw what are prime numbers. So prime numbers are those numbers which are divisible by 1 and the number itself, right? So we had discussed the logic in the last video that we start iterating from 2 and we try to divide the number by 2 and then by 3 and then by 4 and then by 5. And if the modulus of any of these numbers is 0, then it is not prime because it is completely divisible, right? So we will be applying the same logic here for this video also. The only difference is that we'll be doing it for each and every number which is in the range, right? So let's start this video and the problem by creating a class called prime till n, right? Okay, let me create this class and we have to take two inputs, right? So we take inputs. Let me copy this code over here to take inputs. Let me name it as low, and then we have to do it again for a high range, right? Lower will be the right word. Enter. Okay, so we will be iterating over all these numbers from low to high. Okay, so we'll be iterating from low to high, right? We'll be we'll be checking if the numbers are prime or not. So we check so this inner for loop is for checking if the numbers are prime or not. So we'll start from 2 till the number which is I, and we keep on incrementing j, and we check if I mod j is equals to 0. Okay, and before that we declare a boolean is prime, right? Like we set a belief that the number is prime, and what we try to do here is that we try to contradict that belief, right? Okay, I mod j. Okay, and if the modulus is 0, then we set is prime to false, right? And then we break from this statement. Okay, and at the end of this, if we have the number as 2, or then we print a 2, or the is prime flag if true, then we print the number, right? So if is equals to 2 or is prime, right? Then we print that number. Yep. And we had seen a more optimized way for this, right? So this should be less than equal to, because the limits are included. So all the factors of a number, they will occur before its square root, right? So if we take square root of I, we have to do something like maths dot square root. But instead what we did in the last video was that we squared both the sides, right? And the advantage of this approach is that the time complexity for this is reduced. Like earlier it was O of n for this loop, now it is O of root n, right? So that's the advantage of having this g square less than equal to I. So let me run this again. Let's say enter a lower limit 6 and 24. Yep. So let us verify it from here once. 7, 11, 13, 17, 19, 23. 11, 13, 17, 19, 23. Yep, that's right. Let's move on to the next one. Okay. For in the next question is we have to print Fibonacci numbers till n. Okay, let's read the question. You have to print the first n Fibonacci numbers. Take as input n the count of Fibonacci numbers to print. Print first n Fibonacci numbers. So let's first discuss what exactly are Fibonacci numbers, right? So the Fibonacci series, it starts with 0 and 1. So mm, the next number in the series will be the sum of the previous two numbers. So the next number will be 1, and the next number which follows this is the series is the sum of these two, which is 2. The next number is the sum of the previous two, which is 3. Okay, and you can continue on 5 and then 8 and then 13, right, and so on. So we are given a number and we have to print the Fibonacci number till that given number, right? So let's try to solve this. We have create a class first, fib till n. Okay, we take an input, sorry, yep. We first take an input, let's say num. We have to print all the Fibonacci numbers till this num. Okay, so here I'm creating some variables. So the first variable I will be creating is previous, okay, which is 0. And let's say the next or the current variable is 1. So these are the starting variables of the Fibonacci, right? Okay, so now previous is equals to 0 and current is equals to 1, and we have to print the first we have to print these numbers, right? So what I'll do is I'll create a for loop, okay, and we have to print till the number, right? So what we'll do is that we'll print previous. Okay, so for the first iteration we print the previous number, which is 0. Now what we have to do, we have to replace previous with the current one. So we have to swap the variables basically, right? So if we replace the previous with the current one, then we will remove whatever value was present in previous. So what we do, if we create a temp variable and we store previous in it. Okay, and now we assign previous the value of current. Okay, and as you see, the value of current will be the value of previous, which was temp. Okay, plus the value of current, right? If you see, the next number will be the addition of the previous number, previous two numbers, right? So that is the logic we have coded here. So I think this should work. Let's give it a try. Okay, let's print of 10. Yep, 3 plus 2 is 5, 8 plus 5 is 13, 13 plus 21 is 34, right? Yeah, so that was all for today. See you guys in the next video. Bye bye.